So the purpose of this video is to just demonstrate how simple plugin for Rhino functions. The plugin is designed for analysing view quality in Stadium. I'm just going to run through some of the basic functionality. I've got here a little test case base model that I want to do some analysis on. You can see there's a set of points here that represent the eye locations of the spectators. There's a plane of area lights above those points, which is very important. A pitch, which is actually a surface, a point in the center of the pitch, a point over here, which is a reference point for sorting. And that's basically all I need to do some basic analysis. So the plugin is called Seat View, and I'm just going to run through setting it up. So first of all, I have to specify a folder where I'm going to place my output, and then define the edge of the pitch, which is a closed curve, reference point for sorting the spectators, focal point, which is the point that the spectators look at, and then choose a set of eyes. So I'm just going to pick a block of eyes from the corner here, and you can see that I've chosen just over 1500 spectators. So this is doing what we call, or currently referred to as A-value analysis, which is to measure the projected area of the pitch at the spectator's viewing plane. So we can set the plugin up to either use a dynamic field of view, or a static field of view, or no field of view. And this is essentially a masking device that represents what happens when a spectator moves their eyes essentially 30 degrees either side of the center line of their view cone. This is the supposed view cone for a spectator looking straight ahead, and we use these to mask out the information that we're not interested in. Alternatively, we can choose to not use a view cone at all. So the basic way the analysis works is we set it into shaded view, so you can see the pitch there coloured green, and on my desktop I have a file called Seat View, currently almost empty, a couple of old folders and an image which I'll talk about in a minute, and some data that's been collected. We're going to delete that data and go back to Seat View, go into this advanced. We can specify the size of the image that's captured at each spectator's view position. We're going to choose to save the images. So then I hit Start Analysis, and the little processing bar tells me how far we are through. And as that's happening, we can go back to the folder that I've chosen, and you can see those views. We're starting to collect them there as little tiny JPEGs. Quite crude resolution. You can take a closer look at one of those. And what's essentially happening is that we're going to count all the green pixels inside this cone of view, and that represents the area of the pitch that that particular spectator can see. You can see this masking zone has been applied over the top. So as we're doing that analysis, we're also calculating the C value and storing the XYZ coordinates. This is also set up to look at the possible obstructions, so you can set up spectators in front and essentially measure the area that's being obstructed by the backs of other spectators' heads. So we completed the processing there, and the next step is just we can write that data straight out into Excel. You can see there's a button here for reading data in, so once you've done some analysis, you can import that back in for further graphic manipulation, so you don't have to do the analysis every time. So that Excel file takes a few seconds to write. We should find out that it's complete in a second. So the Excel file's been written. We can go into our file. So here's those 1500 views. You can see further up we get more green area. Let's have a look at this. And this is the range of Z values. We're really interested in C values. So here's the range of C values today. You can see some zeros, which are the front row of an upper tier, and A values, which are essentially counts of pixels. So once I've done that, I can store that data and I can come back to it in the future, or I can come back into Rhino, and let's switch to a wireframe view. Let's just see what we can do with that data once we've got it. So I'm going to switch off some of this information here and just leave myself with the pitch. Zoom in on that corner, so we can graphically represent what's coming out, and we can choose whether we're going to represent A value or C value. I'm going to specify an absolute scale for the C values, and I'm going to start from 0, and I know that the maximum is around about 100, and I can choose whether to do points or planes. I'm going to do planes, set the size of those planes, click on that, and you can see there we get a colour scale representation. Looks like there's some that are outside of the range there, so maybe that's worth just deleting, just increasing that and taking another look. Slightly smoother range. You can see that the lowest ones at the front of the tiers where we have zeros are shown up as red, and then the green are the slightly more higher quality, higher values for C. So we can also do the same thing for the A values, and I happen to know that the A value range is from around a maximum of 2,600 and a minimum of 700. I'm going to do it again with the planes. Click on that, turn off C values, and now you can see colour scale representation of the A values there. We can also do it with points, which is very fast. So if you've got a huge file, it's quite useful to output the points. Another piece of functionality I've been working on is taking those stored JPEGs and representing them all simultaneously in a single file, so we can map them all onto their relative position around the stadium, and that's pretty fast to do as well. So that's a previous one. I'm going to get rid of that. Come back into Rhino, and then go to this graphic tab here, and we can set this up to sample every 2 rows, every 2 seats. Click on composite image, go back to our output folder, and then you can see we're starting to build up a composite set of all the views, or a sample set through that corner. You can go back into Rhino again, change that to every single row, every single seat, create that composite image. Should have then updated. It's getting a little dense there, but gives a kind of interesting impression of how the views vary through the stadium. So I've just switched to a model here where I've done the analysis without any view cones, just to demonstrate the difference there. We can generate that composite image, this time without the layer masks, and I've yet to try this out over a full seating bowl, but I think the ability to graphically comprehend the concept of the A value is quite clear.